Hello. In this video, we're going to be talking about congruent polygons. Congruent polygons are congruent if their corresponding sides and angles, the matching parts, are all congruent. So that's what's happening right here. So all of these sides have a pair that they're congruent with, and all of these angles have a pair that they are congruent with. So we're going to write a congruence statement, so not T, C, E. Congruent statement where we're going to say one of our triangles is congruent to the other triangle. Now you only put this little guy here if it's a triangle. Otherwise, you just list those letters. We're going to write our letters. You can do it in any order you like. I like to go 1, 2, 3, just to make sure that I keep them in the same order. So J-E-T. But if I'm going to go 1, 2, 3 on this one tick, 2 tick, 3 tick, I got to go 1, 2, 3 on this one tick, 2 tick, 3 tick. So JET is congruent to BLU. And that is our congruence statement. Now, I could have done that in other orders, and you can see that in this next example. We've got love is congruent to you. So this person did it in that order, but this one spelled you in a different order. We're really kind of like talking about this shape over here. What you can do is you can just say, hey, well, I got to follow the same order of this one, should be the same order in this one. So here, U was the last letter on this thing. So when I write my congruent statement, I want to make sure that E is first. So U is last. Now U and E are first, because these two need to be congruent to each other. So they need to be in the same relative spot. O and V were in the middle, so we're going to keep that in the middle. And then the other piece, L, was on the end. So L was at the beginning, Y was at the beginning, Y is at the end, L is at the end. And we need to do that because these two things are congruent to each other. The other thing you can do with this is if LE, we know it's got to be congruent to another piece. L and E are the first and last letters, so they got to be congruent to another piece here that is the first and last letters. So in this case, Y and U. Now note, it still works on this one. So this U and that Y are rather E and the L, the Y and the U, the E and the L, the Y and the U. So the first and last here in this statement, the first and last in here in this statement still gets us that same sort of thing, that those sides have to be congruent. Now, when things are congruent in math, that lets us like solve little equations in math. So here we've got angle A and we've also got angle D. And they're both in the first spot, so I know that those two things have to be congruent. So based on this information, I know some more things, but really the first idea I want to write is that the measure of angle A has to be equal to the measure of angle D. Since they're in the same relative spot in this statement up here, that means those two bits have to be congruent. Well, if the measure of angle A is x plus 10, and the measure of angle D is 2x, from right here, that gives us a little equation that we can solve. So let's just solve that thing. I've got x's on both sides, so I want to get x's on the same side. So that's telling me, hey, I got to subtract an x from both sides. So 10 equals x. So boom, I determined the value of x by setting two pieces of those triangles that are congruent equal to each other. And I know that because of this congruence statement. Now, it's all well and good when we already know that things are congruent to each other, but a major thing we're going to do in this unit is prove that things are congruent. And right now, the way we're going to do that is we're going to just identify all of our sides, identify all of our angles, and make sure that they all match up. So some of it is already marked in this diagram over here. So this little tick mark is telling me that this side BK is congruent to this side over here. So BK has got to be congruent to KO. So this side and that side. I also know that BR, this side up here and this side up here, I know that those sides are congruent because of those two little tick marks there. So then BR is going to be congruent to RO. Now, as we do these little proofs, we want to make sure that we're showing why we're able to do what we're doing. So these bits of information, I just looked at my diagram. They kind of gave it to me from that diagram. So these two bits of information were just given to me because I didn't do any real thinking. I was just like, well, right there, they're marked congruent, so they are congruent. I'm going to skip down to the angles because we've also got some angles that have been marked congruent to each other. So I know that this angle is congruent to this other angle here. So I need to talk about how angle K is going to be congruent to, well, angle K again. Well, since it's not really clear where K is, I need three letters to name this angle here. So I could say RKO is congruent to RKB. Use three angles to label an angle if it's not clear. And again, I just saw that on the diagram, so that's given. I can do the same thing with angle R up here. So I know that these are congruent. They're just marked congruent in the diagram. So I can say that angle BRK, so this angle right here is BRK. That's going to be congruent to ORK. And again, that was just given. I just saw it in the diagram. Now we need two more pairs of parts. We need another side and we need another angle. So the next side that I still haven't gotten is this side right here in the middle, this little side right here. Um, in order to get that one, we're going to use this property up top. Parts are congruent to themselves. This is the reflexive property. Angle A is congruent to angle A. Side AB is congruent to side AB. So in this one, that RK in the middle, that's got to be congruent to RK. RK is the same as RK. That's the same thing twice. So this is the reflexive property. Now we've got one more angle to deal with, and we're going to use little theorems to help us out here and there. Here's one that's helping us in this problem. If two angles are congruent to two angles of another triangle, hey, that's happening right here. I got two angles in this triangle, two angles in this triangle over here. Then the third angles are congruent. So B and O have to be congruent. So angle RBK has got to be congruent to angle ROK. And this one is using this theorem. You could write that theorem number, but I like to think about this theorem as the triangle angle sum theorem. And that lets me mark these angles as congruent. Now that I've gotten all those pieces, now I can write my congruent statement. So I want to be careful with that congruent statement. I want to kind of go that 1, 2, 3. Follow that nice order as I set these two triangles congruent to each other. So I want to use the first angle, the second angle, and the third one. So KRO, that's got to be congruent to angle KR. I did KRO before, KRO, KRB. That's done. All right, now in this one, They didn't label anything in my diagram, but they still gave me a lot of information. So I know that we've got this thing right here. That's telling me that those two lines are parallel. So I'm going to mark them parallel in my diagram. So I don't have to try to remember it from the given. I can just kind of like see it on there. So those two sides are parallel. And they told me that AD equals 4 and BE equals 4. So both of these sides are 4. All right. What else we got? We've got this whole big thing, AC equals 7, which equals EC. And then we got, I'm just to kind of like separate it out a little bit. These two are also equal, but it's really just saying, hey, everybody here is 7. So I know DC and BC are 7, and AC and EC are 7. And I could have made those all the same color because they are all the same length, but it helps kind of distinguish visually like, hey, I got different pairs of parts. Because that's what I want to do next is I want to list out the pairs of parts and why I'm able to say that those bits are congruent. So I've got these two. These two are the same. They're both 4. So I can say that AD is congruent to BE. And this was just given to me. That was just in that given information. Even says given up there. So if you're just seeing the diagram, it's something that they wrote over here. You just write given because they just gave it to me. Another pair of parts is we've got those sevens. I'll do DC and CB. So DC is congruent to CB. And again, that was just given to me. And then I can also say AC equals EC, this 7 equals that 7. So I can say AC is congruent to CE. And again, that was just given to me. It was part of that given information. Now, all the sides might have been given to me, but they didn't give me any of the angles. So I'm going to have to interpret it based on this diagram and probably these parallel guys. So I'm looking right here at C, and I think those two angles right there, those two have to be congruent because they are a vertical pair. They're parts of this X shape right here. So warp, warp. So those two have to be congruent. I'm going to need 3 letters to name it. So A, C, D. So A, C, D. That has to be congruent to BCE. Oh, forgot my angle symbol. BCE. So this angle has to be congruent to that angle. Oh, and I can do this because they are vertical angles. Now the next part, I've got these parallel lines, and I should use those parallel lines for something. And one thing I'm thinking about is I remember something about if you draw 2 parallel lines and then draw a line through it like that, these two were congruent. These two on alternate sides of this transversal that are inside of 2 parallel lines were always congruent. So these two have to be congruent. That makes these two angles congruent because those question marks are in the same sort of relative spot of A and E. So that means angle, and since there's just one letter there, I can just use the one letter. A is congruent to angle E. And you could use more if you want. It doesn't matter. But because of this, I can say that they are congruent by the alternate interior angles theorem. Alternate interior angles were congruent. And fortunately, we can do this one more time. If I think about this angle here and this angle up here, I can do that same parallel line trick. I'm just going to go up instead of down. This one And this one, this is B, and this is D. They are alternate sides of this transversal. D is above, B is below, and they're in between these two parallel lines. So we can say angle D is congruent to angle B by the, and I'll just abbreviate this time, alternate interior angles. Now that we've got all that, we can write our congruence statement. I would follow these tick marks to make sure that I'm going to mark them in the right order because I don't want to go 1, 2, 3, and then go 1, 3, 2. That's madness. 1, 2, 3, 1, 2, 3. So I'm going to say that triangle CAD is congruent to triangle CEB. And that is all done. So keep in mind, if two shapes are congruent, that means all of their angles have to be congruent and all of their pairs of sides have to be congruent with each other. As you write statements like that, be ready to write the reasonings that go along with them. Thanks for watching. Bye-bye.